Assalamualaikum and hi to everyone. Right, so in this video, I'm going to continue our discussion for the exercise question in my lecture that we have interrupt yesterday. Okay, so we have Kc for hydrogen and plus iodine. Okay, H2 gas plus I2 gas produce 2Hi gas, and the reaction is 54.4 Kc at temperature 698 Kelvin. So if you are given 0.1 mole of hydrogen and 0.1 mole of iodine are filled in 10-liter container at 698 Kelvin until equilibrium obtained, what are the concentration of H2, I2 and Hi at equilibrium? Okay, so basically for this question, you are given the initial mole, okay, you are given the volume, okay, this is initial mole. So initial mole is 0.1, okay, so mole is 0.1, okay, same for hydrogen and iodine. So this one is volume, and then you have temperature, okay. Alright, so if you have mole, volume and temperature, so we can find concentration first, huh? Okay, so concentration, the concentration for hydrogen is equal to 0.1 mole over 10 liter, okay, which is this one also because same concentration for iodine, okay, concentration iodine dan hydrogen sama. Okay, so kita dapat berapa? 0.01 molar. So this is the concentration, initial concentration of hydrogen and iodine. Okay, right. So find the concentration at equilibrium, and then from the Kc given, okay, daripada the value of Kc. Okay, so this one kita perlukan ICE table, ice table. Alright, so let's try to create our ice table. Okay, so kita ada hydrogen, we have hydrogen gas plus iodine gas and produce hydrogen iodide gas. So this is 2. So the initial mole just now, okay, initial mole yang kita dah kira daripada awal tadi ialah 0.01 molar, okay, 0.01 molar. So this one initially is 0. Okay, so this one is in the unit of mole. So the concentration change is minus x plus 2x. So concentration at equilibrium is 0.01 minus x, 0.01 minus x. So this one is 2x. Okay, so kita dah ada concentration for each reactant and product. Okay, so jadi daripada sini kita akan write the expression for Kc. So expression for Kc is equal to concentration hydrogen iodide over concentration of hydrogen times concentration of iodine. So hydrogen iodide is 2 mole, okay, jadi kita kena darab kuasa 2. So Hi, because Hi here is 2x, okay, so kita substitute 2x square over 0.01 minus x square, okay, equal to Kc is 54.4. Alright, so we rearrange the equation, okay, 2x square, okay, 2x square dia akan jadi 4x square equal to 54.4 times 0.01 minus x square. So this one kita expand the equation, then rearrange the equation, okay, so it becomes equal to 54.4 exponent negative 4, okay, minus 1.088 x plus 54.4 x square. So this one just now ada lagi sini, 4x square. So kita jadikan this one is 0, so so that kita ada ax square plus bx plus c is equal to 0. Okay, so bila kita rearrange the equation, it becomes, so this one 54.4 minus 4, it becomes 50.4 x square, okay, minus 1.0 x, okay, plus 54.4 exponential negative 4 equal to 0. So this is our quadratic expression yang bersamaan dengan ax square plus bx plus c equal to 0. Okay, so our a is 50.4, b is negative 1.088, c is 54.4. Okay, and then substitute in your calculator. If you are using the normal calculator, fx 570 es plus, okay, you just press mod, okay, and then 5 equation, so 3, okay, so you choose 3, ax square plus bx plus c. Okay, so solve for the expression, you akan dapat x1, okay, x1 is equal to 7.866 exponential negative 3, x2 equal to 0.013705. So, yang mana kita mau ambil? X1 ataupun X2? Okay? X1 ataupun X2? Which one? Okay? To be chosen. Jadi, cara dia senang je. Kita kena substitute. Okay, we need to substitute this value into this equation. Okay? Gantikan salah satu nilai X di dalam equation ini. So, both are positive. Jadi, kita tak tahu yang mana kita akan pilih. So, let's say kalaulah kita ambil X1, okay, kita gantikan di dalam concentration of hydrogen, iodine, and hydrogen iodide, semua akan jadi positif. Okay, tapi kalau kita ambil X2, if we choose X2, 0.013705, kita gantikan dalam ini. So, 0.01 minus 0.013. So, automatic dia akan jadi negatif. So, kita akan tidak pilih X2. Kita akan pilih apa? We choose X1. So, now we substitute the value of hydrogen, which is equal to the concentration of iodine, which is equal to 0.01 minus X. Where our X just now kita sudah pilih 7.866 exponent negative 3, okay, minus 7.866 exponential negative 3. So kita akan dapat berapa? We got 2.13. Okay, we got 2.13 for exponential negative 3 molar. The concentration of hydrogen iodide equal to 2x, okay, which is equal to 2 times 7.866 exponential negative 3. So kita dapat berapa? We got 0.01573 molar. Okay, so that's for question number exercise 1. Okay, so we proceed to the next exercise. Okay, for this exercise, ini yang kita start masa kelas online kita. Okay, exercise 2. You are given 0.1 mole of dinitrogen tetroxide, okay, and then it is placed in 22.4 cubic decimeter glass container and allowed to equilibrate at 100 degrees Celsius under a pressure of 2.46 atm. Calculate the partial pressure of N2O4, NO2, and Kp and Kc. Jadi yang ini adalah concentration. Dia suruh kira pressure at equilibrium. Jadi untuk initial pressure kita akan gunakan PV equal to nRT. Okay, we use PV is equal to nRT. Jadi first we calculate pressure dahulu. Okay, kita kena calculate pressure. So pressure of N2O4, okay, pressure of N2O4 is equal to nRT over V. Okay, so mole dia tadi di sini 1 mole, okay, 1 times 0.08206, temperature is 373.15 over volume is 22.4 liter. Okay, so kita akan dapat 1.3669 atm. Okay, so this is the pressure initial lah. Initial because initially it is placed di dalam the system, okay, in the system. So the system is N2O4, okay, gas produce 2NO2 gas. Okay, so N2O4, okay, N2O4 pressure for initial pressure there is 1.3669, and then this one initial pressure there is 0. Sebab dia tak bagi apa-apa mol, okay. Alright, so the change in pressure is, so this one we put ATM, don't forget to put ATM. So this one is minus X, this one is plus 2X. So pressure at equilibrium is 1.3669 minus X. So this one is 2X. Okay, so kita dah ada expression kita. Then kita tengok dekat dalam question, dia bagi allowed to equilibrate at 100 degrees Celsius under a pressure of 2.46 atm. Meaning that, okay, at equilibrium, this pressure, these two pressure, total dah, okay, P total dah is equal to 2.46 atm. Jadi 2.46 atm equal to partial pressure N2O4 plus partial pressure N2NO2. Jadi kita tambahkan saja di sini 1.3669 minus X plus 2X. Jadi kita solve untuk X, okay? So for X, we got X is equal to 1.09. So bila dapat 1.09, then barulah kita boleh substitute the value of X in this expression. Okay, gantikan nilai X di dalam pressure at equilibrium. Jadi pressure at equilibrium, okay, pressure at equilibrium untuk N2O4 equal to 1.3669 minus X, okay, which is equal to 1.3669 minus 1.09. So we got berapa ni? 0.2769 atm. Okay, alright. So given answer is 0.274. Okay, so boleh lah. Okay, alright. And then pressure for NO2. Okay, pressure of NO2 ialah 2x. Okay, which is equal to 2 times 1.09. So we got 2.18 atm. Okay, so this is pressure of N2O4 and O2. Next, calculate the Kp and Kc. Okay, so Kp, okay, Kp is equal to partial pressure NO2 square over partial pressure N2O4. Jadi kita dah ada partial pressure tadi untuk setiap gas, okay. So 2.18 square over 0.2769. Okay, so dapat Kp dia berapa? 17.44 Kp. Okay, next kita nak kira Kc. Kp is equal to Kc RT delta N. Okay, so Kc is equal to Kp over RT delta N. So delta N here is, okay, so delta N kita tengok di sini. Okay, 2 minus 1. Okay, so 2 minus 1 is equal to 1. So this one is 1. So Kp kita dapat 17.44 over, okay, R is 0.08206. Okay, temperature is 373.15. Power of 1. Okay, alright. So solve for this, kita dapat, we got 0.57. Okay. Okay, so that's all for exercise number 2. Alright, so we continue to question exercise 3. Okay, to exercise 3, you are given ammonium hydrogen sulfide decomposes at 250 degrees Celsius. So, which is later kita kena tukar pergi convert to ATM. This one to 7. This one to Kelvin. Okay. Alright, so NH4HS solid, NH3 gas plus H2S gas. So Kp given is 0.11. Okay, this is Kp. So if you are given 55 gram of solid, okay, it's placed in sealed 5 liter container, what is the partial pressure of ammonia and H2S at equilibrium? Okay, so dia bagi Kp. Okay, you are given the Kp. Right, so kita cuba let's try. Okay, mula kita lukislah apa? ICE table. Okay, alright, so for ICE table, okay, the ICE table is NH4H, okay, NH4HS solid, okay, produce NH3 gas plus H2S gas. Okay, so pressure initial, this one. So this is the trick. Nampak tak? Dia beri solid di sini. Actually kalau tu solid kita just put dash here. Okay, so this one is initially is 0, 0. So the change in pressure is dash here. This one is plus X. Then this one is also plus X. So pressure at equilibrium is dash here. And then this one 0 plus X is equal to X. 0 plus X equal to X. Okay, so Kp is equal to partial pressure NH3 times partial pressure H2S. Okay, which is equal to X times X ataupun X square. So value of Kp given is 0.11. 0.11 equal to X square. So X is equal to square root 0.11. Okay, so we got 0.33. Okay, square root 0.11, 0.33. So 0.33 ialah nilai X. Jadi X is in the ATM. So partial pressure for NH3 equal to partial pressure of H2S equal to 0.33 ATM. Okay, that's all for question number 3. Okay, so kita pergi kepada question number 4. Alright, exercise 4. You are given 1 mole each of SO2 and O2 are introduced into an evacuated 2.25 liter flask at 345 Kelvin. At equilibrium, the total pressure of gases mixture is 24 atm. Calculate the value of Kp. So Kp given is 4.51 for exponential -3. Right. So first of all, okay, for this type of question, okay, kita perlu this one we need to write ICE table. Okay, kita perlu write dia punya ICE table. So you are given the number of mole. Okay, kita tengok number of mole equal to 1 mole. Okay, and then volume is equal to 2.25 liter. Okay, temperature equal to 345 Kelvin. Jadi kita ada mole. Okay, so find Kp. Kita nak cari Kp. Okay, alright. So temperature, and then dia bagi at equilibrium. Okay, total pressure equal to 24 atm. So kita boleh calculate pressure initial for SO2 dan juga iodine. Okay, so pressure initial for SO2 equal to pressure initial for oxygen, which is equal to nRT over V. Okay, nRT over V. Di bilangan mol kita is 1, R is 0.08206. So the temperature is 345 Kelvin over 2.25 liter. Okay, so solve for P. Okay, selesaikan untuk P. So pressure kita akan dapat, okay, let me use my calculator. Okay, 12.583 atm. Okay, so this is the initial pressure for the gas. Jadi write the ice table. Okay, write the ice table. SO2 plus O2 produce 2 SO3 gas. Okay, so pressure initial, this one is 12.583. 12.583 initially 0. So pressure change is minus x plus 2x. Pressure at equilibrium is minus x, 12.583 minus x, 2x. So given P total, okay, you are given the P total here tadi. P total is equal to 24 atm. Jadi P total is equal to 12.583 minus x plus 12.583 minus x plus 2x. Jadi kita selesaikan untuk x. Okay, kita akan dapat x is equal to 1.165. Then we substitute balik ya. Kita substitute semula di dalam into here. Nilai-nilai x di sini. Okay, substitute di dalam nilai x, ataupun kita boleh terus tulis Kp. Okay, write the Kp. So Kp is equal to partial pressure SO3 square over partial pressure SO2. This one we have 2 from the balance equation, square times partial pressure O2 Kp. Okay, so kita gantikan nilai-nilai di sini. Okay, right. So partial pressure of SO3 2x. Okay, so 2 times 1.165 okay, square, okay, over SO2. So SO2 is 12.583. Okay, 12.583 minus 1.165 square times P oxygen is 12.583 minus 1.165. Okay, use your calculator. Okay, and then you will got 4.53 exponential negative 3. Okay, so final answer given is 4.51. Okay, so boleh lah. Okay, 4.5, this one 4.53 exponential negative 3. Okay, alright, so that's for question exercise 4. Okay, we proceed to the next exercise. Exercise 5. So for exercise 5, we have NaHCO3 solid, okay, produce Na2CO3 plus CO2 gas plus H2O gas. You are given Kp. Kp is equal to 0.23 okay, at 373 Kelvin. A sample of NaHCO3, okay, sodium carbonate, is placed in an evacuated flask and is allowed to achieve equilibrium. What is the total pressure, gas pressure at equilibrium? Total gas pressure at equilibrium. Okay, so you are given Kp, okay. Alright, so rewrite the equation. Okay, tulis semula equation ini. 2 NaHCO3 produce Na2CO3 plus CO2 plus H2O gas. Okay, you are given the Kp. Kp is 0.23. So pressure initial again, nampak ni, this one is solid, this one is solid. So for solid we just put minus, so not minus, dash, meaning that no, and this one 0, okay, and then here is 0 initially. So the change is dash, this one is plus x, this one also plus x. Pressure at the equilibrium, dash, 0 plus x, 0 plus x. So Kp is equal to partial pressure CO2 times partial pressure H2O, okay, which is equal to x times x, and equal to, given Kp is 0.23. Okay, so x is equal to 0.23. So the answer is 0.48. So X is pressure of carbon dioxide. So pressure of carbon dioxide, this one is at equilibrium. Pressure of carbon dioxide equal to pressure of H2O gas equal to X, which is X is equal to 0.48 atm. Okay, so kita dah dapat partial pressure for carbon monoxide. Carbon dioxide and water. So what is the total gas pressure at equilibrium? So P total is equal to P carbon dioxide plus P H2O. So 0.48 plus 0.48 equal to 0.952 atm. Okay, right. Okay, so the last question, question number 6. So question number 6, you are given hydrogen gas plus carbon dioxide gas produce carbon monoxide gas and H2O gas. Jadi kita dah ada gas pressure, mole of each gas reactant. Okay, jadi tetapi dia tak bagi apa-apa. You are not given temperature, no volume. Okay, tiada volume. Jadi kalau tiada volume, kita assume volume is equal to 1 liter. Okay, volume equal to 1 liter. Then kalau kita nak cari concentration, okay, to find concentration, so concentration of hydrogen equal to concentration of hydrogen given is 4 mole. Jadi 4 mole over 1 liter. Okay, apa yang kita buat tadi saya explain. Kita assume kita ada V sama dengan 1 liter. 1 liter volume of the gas. Okay, so then 4 over 1 equal to 4 molar. Okay, and then concentration of CO2 equal to 0.9 molar. Mole over 1 liter equal to 0.9 molar. Jadi kita dah dapat dia punya molarity, okay, dan kita boleh calculate dia punya apa? Unstable, unstable. Okay, so H2 gas plus carbon dioxide, okay, produce CO gas plus H2O gas. So concentration initial tadi yang kita dah dapat, this one is 4, this one is 0.9, this one is 0, initially 0. So molarity. So the change is minus x plus x plus x. Concentration at equilibrium, 4 minus x, 0.9 minus x, x. Okay, so apa yang dia bagi dekat situ? Okay, 0.1 mole of carbon dioxide was found in the equilibrium mixture. So maksudnya carbon dioxide ini dia dah bagi. Okay, this one is equal to 0.1 mole. Okay, jadi maksudnya di sini kita boleh buat cari nilai x. 0.9 minus x is equal to 0.1. So x is equal to 0.8. Okay, kita dah dapat x, kita boleh substitute nilai x di sini. Okay, 4 minus 0.8. Okay, so for concentration of hydrogen is equal to 4 minus x, di mana x is 0.8. So we got 3.2 molar. So concentration of carbon dioxide is 0.1 lah. Okay, alright. So for CO is equal to x, which is equal to 0.8 molar. And then concentration of H2O equal to x, which is equal to 0.8 molar. Jadi kita dah ada nilai 3.2, 0.8, 0.8. Okay, and then this one is 0.1. So we can write the Kc, okay. So Kc is equal to concentration CO times concentration H2O over concentration of H2 times concentration of CO2. Substitute the value yang kita dah dapat tadi, 0.8, 0.8, 0.1, 3.2. So CO 0.8 times 0.8 over hydrogen is 3.2 times 0.8. Sorry, this one is 0.1. Okay, carbon dioxide. So ini kita ambil di sini lah. Okay, right, so solve for Kc, we got Kc is equal to 2. Okay, so that's all for our exercise number 6. Okay class, thank you.